the number of possible positive, negative, and non-real root situations that might happen in the roots of an equation of polynomial with real coefficients. This is called Descartes' rule of signs, and by actually knowing how many of each type of root we expect or the different scenarios that could possibly occur, it helps us to focus our attention on, let's say we know that we have at most 2 negative roots. So if we found 2 negative numbers that are solutions of the polynomial equation, we know not to check in the negatives anymore for the remaining roots if we haven't found them all. So it does help us focus our attention to be able to solve the polynomial equations later on. So this is called Descartes' rule of signs, and it goes like this. If a polynomial p of x has real coefficients, the number of positive roots of the equation p of x is equal to 0 is either equal to the variations in sign of p of x or less than that by an even number. So now the reason it's or less than that by an even number is that in an earlier video, I discussed how if you have a polynomial equation with real coefficients and a complex number with a non-zero imaginary part is a root, then its complex conjugate has to be a root also. So non-real complex conjugates come in conjugate pairs if you have real coefficients of your polynomial. And there's no way to really sort out when there's a conjugate pair hiding in our count in our variations. So when we count the variations, that's our highest number of that type of root we can have, and then we have to keep subtracting off 2 till we can't subtract off 2 anymore for the situations that maybe there's a conjugate pair hiding in the list of roots. Now, that's how you find the number of possible positive solutions to a polynomial equation. The number of negative roots of p of x equals 0 is either equal to the variations in sign of p of negative x, so put minus x in for all the x's, take it to the appropriate powers and simplify, or less that by an even number. Again, I might have the conjugate pairs hiding in there. And then we're going to make a table of the possible positive, negative, and non-real roots of this polynomial equation, p of x equal 7x to the 5th minus 4x cubed minus 9x squared plus x minus 10 equals 0. So notice it's a polynomial equation. Its exponents are whole numbers on the variables. I don't have any i's as coefficients in front of my x's, so it has real coefficients. And it's in descending order. That's something that's very important in the setup of it. Now, what's a variation in sign? Well, a variation in sign is if when you go from one term to the very next term, when it's written in descending order, if the sign switches the coefficient, the sign of the coefficient switches from either positive to negative, or if it were to switch from negative to positive. That's called a variation in sign. Now also remember that the number of roots that you have in the solution set of a polynomial equation, if you count multiplicity and you also count your non-real solutions, is the same as the highest degree term. So I did look to make sure it's in descending order, that this first term is the highest degree. Always check that first, because if someone didn't write it in descending order, you don't want to go with the first exponent. You need to go with the highest exponent. And to carry out the rest of the process, you would want to arrange the terms so that they go in descending order as well. All right, so I have 5 total roots for this polynomial equation. And then I want to know the possible number of positive, negative, non-real, and my total. So I'm going to make a table with those headings. So it's the number of possible positive, and then the number of possible negative, the number of possible non-real, and then we also have our total. So we'll go ahead and put the total here. So total is 5. Okay, now I will have more lines than that as I find out what my situation is, but I'm just going to remind myself that the total is 5 for now. Okay, so this is in descending order. The coefficient in front of the first term is positive 7, so that's positive. The very next term after it is negative, so positive to negative, that's one variation in sign. Then negative to negative doesn't change sign, so that's not a variation. Negative to positive is a variation, so that gives me 2 variations so far, and positive to negative is another variation. So that gives me 3 variations. So there are 3 or less that by an even number. So if I take 3 and I subtract the even number 2, I'm down to 1 positive roots. So I either have 3 or 1 positive roots. I'm going to make a line for each case scenario. And now also, I can't subtract 2 anymore, but let's say you had another problem and you counted out 5 variations. Then you'd have to go 5 or 3 or 1. You have to keep subtracting 2 too. You can't subtract 2 anymore. If you came up with another problem and it said there were 4 variations in the polynomial, so there would either be 4 or 2 or 0 positive roots. Okay, now the next thing we need to do is find what we have for p of negative x. So we're going to take out the x's and put in negative x instead. Now here you're going to go through and actually simplify this using what would happen with the exponent. So negative x to the 5th power. Negative x times negative x times negative x times negative x times negative x. So if I have 5 negative factors multiplied together, I would have a negative product and then x to the 5th. So negative x to the 5th times 7 is a negative 7x to the 5th. Now negative x to the 3rd, 3 factors of negative x would be a negative product, and then x to the 3rd. So negative 4 times negative x to the 3rd is a plus 4x to the 3rd. Negative x quantity squared, negative x times negative x is a positive product. So positive x squared times negative 9 is still a minus 9x squared. Minus a negative x is minus x, and then minus 10. That last term doesn't have a factor of x, so it's not going to change sign. Now let's count the variations. So the negative coefficient starts, then negative coefficient to positive coefficient, that's a variation in sign. So there's 1. Then positive to negative is another change of sign from one term to the next. That's called a variation in sign, so that gives us 2. Negative to negative is not a variation. Negative to negative is not a variation. So I have 2 variations in p of negative x. So there's 2 or, subtract 2 from 2, you get 0, negative roots. And again, if you would have had a different question and it would have said there were 5 negative roots, you'd have to go 5 or 3 or 1. You just have to keep subtracting 2 till you can't anymore. All right, so I have 2 different situations here. I could have 2 or 0 negative roots. So with my 3 positive roots, I might have 2 negative roots. And 3 plus 2 adds up to 5 roots total already. That's all that I would have, so I wouldn't have any non-real roots in that scenario. Now the next line, remember, you got to have 5 total. So if I had 1 positive root with 2 negative roots, well, 1 plus 2 is 3, and I need 5 total. So I would need to have 2 non-real roots, so they would add up to 5. But I haven't accounted for my 0 negative roots yet. So I need to take each of the cases that I had for the number of possible positive roots with the 0 next time. So here I have possibly 3 positive roots but 0 negative roots. To get a total of 5, I would need 2 non-real, or 1 positive root with 0 negative roots. To get my total of 5, I would need to, in that scenario, get 4 non-real roots. Now, I took each case of the number of possible positive roots with each case of the number of possible negative roots, and I did them one line at a time, and I needed to make sure that the number of possible positive roots plus the number of possible negative roots plus the number of possible non-real roots added up to the total. So here is the entire situation of what might occur for how many positive, negative, or non-real roots you would have for this polynomial equation.